Welcome. In this OnShape tutorial, we're going to be designing a phone stand for laser cutting. So these are the three pieces that are going to go into our phone stand. I've kind of mocked it up beforehand, and then I'm going to take you through the process of creating this in a way that allows us to make changes on the fly and have them be reflected. But phone stand is designed to be cut out of 3mm thick material like wood or acrylic. It's got three pieces. This first piece is meant to drop down into this slot like that, and that'll be sort of a front stop for the phone to keep it from sliding out of the front of the stand. And then these four slots are to give you some adjustability. So this back plate can slide in just like that, and they'll actually hopefully line up all the way. Your phone could then stand up here, and the base of it would be caught by this little tab, hopefully without obscuring too much of the bottom of the screen. And you could rotate your phone either portrait or landscape, and this should work just as well. Depending on the viewing angle you want, you could swap this out for any of these four slots, and you would get a different viewing angle depending on how low compared to your eye line the phone is going to sit. So this is the basic design for our phone stand. From the side, you'll notice it's going to form sort of this triangle. So on some of these slots, it might lean forward. On some, it might lean back. I would say that is maybe an imperfection in the design that we should think about how we could change and improve. But for getting started with OnShape, I think this is going to be a good tutorial for demonstrating quite a few things that you want to be able to do. So I'm going to create a new part studio. When you're creating a new document to follow along with this, you don't need to click New Part Studio. There's already going to be one created for you called Part Studio 1. So when we open OnShape, we see our three planes. We're going to go ahead and start by designing the base, just because that seems to be what the other parts are designed to fit with. This is kind of the most involved of the parts and the most complicated. So we're going to design this thing in the orientation that it's typically going to be sitting in the real world. So we're going to design the base sitting down on our tabletop using the top plane. So I'm going to click once on top plane, and then either I'll click the sketch button or hit Shift S to make a new sketch. I'm going to hit the N key to look normal to my plane so I can look at it head on. And we're going to go ahead and define this base plate using the rectangle tool, which sits up here. We have two options, either corner rectangle or center point rectangle. We want our base plate centered around this origin point, so we're going to use the center rectangle tool, which you can also access by hitting R. So I'm going to click once on the origin, and then I'm going to click again somewhere out here. So now it's time to come up with some dimensions for how big we want this base plate to be. So again, this is something I probably will make and then laser cut out of cardboard and see how it feels in my hands. I might find that the first draft is too big in one dimension or too small in another, and then we can make changes. But what we're going to do is go ahead and give ourselves an initial dimension, which, by the way, I access the dimension tool by hitting the key D. Click once on this line and once out here. And initially, let's go ahead and say that this thing's going to be 8 centimeters deep. So my units are set to centimeters. You can always double check by clicking on Workspace Units. And right there, your length default unit, centimeters, is what we want. So when I'm in Sketch 1, I've got 8 centimeters set for the length of this thing. Now the back part is going to be relevant to more than just this piece. So if we go back to our example here, you'll notice this piece that I'm sliding right now has the same exact width as the base plate. And that's because, form factor wise, I just want them to line up. Technically one could be wider than the other, but I think it looks quite nicely if when these two slots meet each other at the midpoint, we end up with two kind of square shapes that line up cleanly on the edges. And so that means that later on I'm going to want to know the length of this front edge, or we could call it the width of our base plate. So not only am I going to dimension this by hitting the D key, but instead of just typing in a value here, I'm going to hit the pound sign or the hashtag symbol, and I'm going to type in base width, okay, the width of the base. That you'll notice it pops up, it's going to make a new variable. So if I hit enter, I get this little dialog that comes up. It's created a new length variable called base width, and I'm going to type in 8 centimeters. That's what I want my base width to be. So now not only have I defined this as 8 centimeters wide, it's created a new variable called base width that I can reference elsewhere. The nice thing is if I update this value here, not in the sketch, if I update this value for this variable, it'll update everything that relies on it. So for example, if I come in here and I change my base width to be 20 centimeters, which is really extreme, you'll notice my sketch automatically updates because it's referencing that variable. So I'm going to set this back to 8 and double click on sketch 1 again. So here's the basic footprint of our base. And so I'm going to rename this sketch base footprint, footprint, and hit the green check to accept my sketch. So now I want to bring this into 3 dimensions. So I'm going to click once on it and then click on the extrude tool or hit Shift E. And rather than calling this extrude 1, I'm going to call this base. I'm making sure I'm creating a new part. There's nothing to add to so far, but that'll be relevant later. And then in terms of depth, I want to model the material I'm actually going to laser cut this out of, but I have a lot of pieces and features that are going to be based on that material thickness. So instead of just typing in 3 millimeters, again, I'm going to hit the hashtag sign and type in the name I want to call my variable. We'll call it material thickness. And then I'm going to define that as 3 millimeters. That's the thickness of the wood that we typically laser cut here. So we'll hit the green check, and we should see, by the way, to get to this view, you can always just hit Shift 7. If you're ever in like a weird orientation, Shift 7 will take you back to this familiar view. So now we can see it's created a part. We actually have a 3-dimensional part. This represents our base. It's not terribly interesting. It's just a square made out of 3 millimeter wood, but let's go ahead and give our part a name, because we're going to have multiple parts. So we'll rename it and we'll call this base. And let's go ahead and right click, assign material. Oh, not material, I'm sorry, edit appearance. And I usually like to click this first one to make it kind of look like plywood, just to help my brain as I'm modeling this how it's going to look in the real world. Now you might notice on the sort of finished example, we've got some rounded corners that make this thing look a little more nice to hold in your hand, a little less stabby. But we're going to save that kind of feature for the end because it's really nice to be able to just reference off of these hard rectangular lines. So the overall footprint of our base is done. Now it's time to go ahead and add some of these slots that we saw where other pieces are going to plug into this piece. So because we've got a part that we can kind of reference off of, I'm going to hit the P key to hide these planes because we're no longer referencing these imaginary planes so much. We're really just thinking in terms of how do these features sit relative to the part I've created. So if we click once on the top surface of base, we can make a new sketch based on that surface, and we can hit N to look directly at it. So what we're going to do first is that little slot where the front catch is going to go. So again, I'm going to grab my center point rectangle tool by hitting R, and you can see that if I'm near the center line of this part, it's going to snap and say that this is directly centered on the part below the origin. So anywhere in here is fine. I actually do want it to snap there because I want this thing to be centered. So I'm going to click once and then drag out some distance. Doesn't have to look exactly like I want it in the end. And click again. So now I've created a rectangle. This rectangle is blue because I haven't defined several aspects of it yet. Right? It's got a flexible width, a flexible height, and its location is flexible in one direction. I can drag it up and down, but not side to side because it's constrained to the center line. So the first thing I'm going to do is dimension this short edge. So I'm going to grab my dimension tool and click once on this edge, then once to the side. Now this is going to be, this slot has to be wide enough to accept the material we're building this out of, which means we can go ahead and reference material thickness. So if we type in material thickness and hit enter twice, it'll dimension it to, in this case, 3 millimeters. The nice thing is if I were to change this value, it would change not only how far the base was extruded, but also the size of this slot, which is really convenient. So we're going to be using variables a lot because our designs just are going to have to be able to change as we prototype them, test them out, and find mistakes. It's really nice if you've thought ahead and used variables rather than had to go back and find all the 0.3s in your sketch and change them to 0.4s or whatever it is that you decide to do. So we need to define a couple more things. One is how wide is this slot going to be? So we're going to create a new variable because there's other parts that are going to reference this same thing. And we'll call this short slot width. And let's go ahead and put that right. It looks about the right size to me. So let's say it's going to be 1.5 centimeters. So now we've created in the side another variable called short slot width that will reference on other parts and set it to 1.5. Now the last part, and the reason this rectangle is still blue, is because we haven't constrained where it is vertically on the part. So what I'm going to do is go ahead and drop a dimension by clicking on this line and then on this front edge of the base, and now I can dimension how far apart they are. So sometimes I'll use 0.3 centimeters or 3 millimeters because that gives us a little bit of sturdiness here without too much wasted overlap in the front. You may find that that's too thin and too flexible depending on your material, so maybe you want to change that. But I'm going to go ahead and just set that to 3 millimeters there. Let's go ahead and name our sketch so that when we come back to edit our part later, we know what we're looking at. And we'll call this the front stop slot because that's the slot where the front stop is going to plug into the base plate. We'll accept our sketch, and you'll notice our part hasn't changed overall. It's still a solid piece of wood. It now just has this faint rectangle on it. Well, that's because we made a 2D sketch, but we haven't actually brought that sketch into the third dimension yet. So if I click once on it, again I want to use my extrude tool, only now instead of adding material or making a new part, I want to remove material based on my selected sketch. Now I don't want a blind removal, which just means remove up until this arbitrary depth that's set here. I want to remove through all, right? Regardless of how thick this base plate is, I want this hole to go all the way through it. I'll rename this and we'll call it front stop slot again. This is the three-dimensional extrusion of it, and we'll hit check. And now our base has a hole in it that goes all the way through. The nice thing is, if I were to change my material thickness, let's say we made it 7 millimeters, or 7 centimeters, let's make it 10 millimeters. If I change that, you'll notice a couple things have changed, right? One, my base responded to that. It's actually thicker than it used to be. And also, this slot responded accordingly because it's now wide enough in this highlighted dimension to accept some of this material into it. Okay, let's go ahead and put that back to the actual 3 millimeters we'll be using. And you can see that our responsive program is updating things based on the variables that we take time to create names for. So for the next part, let's go ahead and cut in these couple of slots that allow us to put the backplate in at different positions for different viewing angles. Just like we did before, we're going to click on the surface, this main top surface of the base plate. We're going to make a new sketch. We're going to hit N to view normal to it. And we've got a couple of things, a couple of ways we could approach this. What I might do is start by using not the center point rectangle, but the corner point rectangles, or hitting the G key. And I know that I want one edge of my rectangle or one corner to be on this line. So I'm going to just draw a rectangle initially. I'll make it bigger than we need. But the one thing I want to do is make sure that it lines up with the center line and it nicely snaps to that yellow line. That's because for this particular design, I think I want the base plate and the back plate each to have a slot halfway through, and since they're the same width, they'll line up perfectly edge to edge when I can kind of demonstrate this, when we slide this in at the same moment that this line hits this edge. Oh, you know what? I think I thought about that. No, I think that's correct. Our part should lock into place just like that. And if I'm making a mistake now, the beauty is we'll be able to make a prototype and then come back and adjust our sketches. So let's go back into our, I actually accidentally deleted that sketch, but we can grab our rectangle tool. We'll draw a rectangle, making sure it lines up with the center line. And the first dimension I'm going to apply is by saying that this short edge needs to be based on, hopefully you guessed it, the material thickness. So that's going to tell us that this is wide enough to accept another piece of this wood that's going to slide in from this side. I'm also going to say for my backmost slot, by dimensioning this line and this line relative to one another, that I want to leave, let's say, 5 millimeters gap from the back to make this thing a bit sturdy. That looks a little bit short, so I'm going to say instead 7.5 millimeters. I think I like 5. Nice thing is, not 5 centimeters, 5 millimeters. Nice thing is we can change this anytime we want. So this is great, it gives us one slot, but we actually want to have multiple possible viewing angles. So I'm going to go ahead and drop a couple more rectangles in. I'm going to let them snap to this line, but I'm not going to worry about their positions or their sizes too much right now. So I'm just going to drop a few more rectangles in. Here's a nice chance to use the equal constraint or hit E. So first of all, I want all of these short edges to be the same length. So I'm going to click on the one I've set and then click on another, and that sets them equal to one another. So now all of these slots are going to be responsive. If I were to change this material thickness, all of them would change accordingly, which is awesome. They're already constrained to this center line, so really all I have to worry about now is the fact that they can slide up and down. So what we're going to do is adjust these around to where we want our different viewing angles to be. So I know I've set this back one. What I think I may do is go ahead and create some equal spacing. Right? There's a lot of reasons you could come up with different positions for these, and you may find in prototyping that you want to slide them around to non-equal spacing, because that's just kind of the way that you end up wanting your phone to sit. But for the sake of instruction, we're going to go ahead and grab our line tool or hit L, and we're going to turn on this construction tool, which is also accessed by hitting Q. What that allows us to do is to draw these dotted construction lines that tell the computer, hey, I don't actually want to cut based on this. This isn't a real part of my sketch, but I do need a line here for some constraining purpose or some reference. So I'm going to draw one of those for connecting the inside points of each of these sets of slots. So I've drawn 3 construction lines, and now what I'm going to do is dimension them. I'm actually going to dimension just the first one, and I'm going to say, let's go ahead and put in 1.5 centimeters from the front edge of this slot to the back edge of that slot. Now I can use my equal tool and say I want each of these construction lines to be equal in length. So now I have 4 equal spaced rectangles, and I can change that spacing just by changing this number. If I set it to a smaller number, they become closer together. If I set it to a bigger number, they become further apart. This of course is not going to be an okay placement for the front slot. So let's go ahead and put it at 1.5. I think looks good. Again, you don't have to have these equal spaced, but I think it gives us a nice excuse to use construction lines in the equality constraint. So now our sketch is fully black because it's fully constrained, and let's call this backstop slots because those 4 slots are going to be where our backstop is going to slide into the base. We'll hit check. And now again, we can see that our base includes these little sketches on it, but we've not yet extruded them. So we're going to click on the sketch we just made. We're going to click the extrude button. We're going to make sure we're removing material all the way through the part, and we'll call this again back stop slots and hit the check. So at this point, our base is actually looking pretty much complete. We'll add a couple of rounded corners to make it nicer to hold later, but the base is looking done. So what I want to do is I'm actually going to move these variables we created up in the working tree just so I can keep them together. There's no harm in having them defined earlier. You'll notice if I try to drag them down, well, I get red because this base footprint was trying to reference this variable, which now doesn't exist above it in the tree. So I'm going to undo that change. But all of these sketches and extrusions relate to the base. So what I'm going to do is click on the top one, hold shift, and click on the bottom one to highlight them and put them all in a folder. And we'll just call that folder base. This is going to allow me to kind of organize my working tree where I've got my variables at the top. I can see and reference them. And then I've got everything related to the base in this little folder. So with that being said, I'm going to hide this base plate. We're going to hit P to turn back on the planes. And now we're going to start work on our next piece. We could go for either one of these. I think it might be nice to do the next big simple piece next. So we're going to create this back plate. So we'll go back to our part studio. Now this one's going to be in a more vertical orientation. So we'll click on the front plane and we're going to make a new sketch. Hit End for normal. And again, we're going to want to use a rectangle to lay out the overall form factor of this backstop. So I'm going to choose a center point rectangle, and I'm going to click somewhere on this line above the origin. There's a lot of ways you could define this part, my personal preference would be to define it centered on this line, but somewhere up above the origin. So I'm going to just lay in the general shape of my part. I'd like it to lie where this edge is on this plane down here. So I'm going to hit I or use the coincident tool to say that this line falls on this plane. And now it's time to just dimension the last two parts. Right? I haven't dimensioned its width or its height, only where its bottom edge lies. So its width needs to match the width of the base. So I'm going to click here, and instead of typing in a number, I'm going to start typing base, and you'll notice I can select that variable I set before. The great thing is if I update base width, now it'll update both of these parts automatically. The height is kind of up to me. I think I'm going to go with 7 centimeters tall. We'll see when we make an actual prototype if that's too tall or too short. But this is going to work for the position and dimensions of our backstop. So we'll call this backstop. We'll hit the green check. And now it's time to bring that 2D sketch into the third dimension using the extrude tool. Now, if you haven't hidden your base part, this might choose to try and add material to the base. We want to make sure we're creating a totally new separate part by clicking new here. Blind is fine, but for depth, we want to reference that material thickness variable again so that this is set to the actual thickness of our material, our wood, and we'll call this backstop. That's the extrusion. So we've created now a second part, which it's named part 2. We're going to name backstop. And if we look at both of them, right, they kind of overlap each other in an impossible way in space, but that's fine. We're not doing the assembly yet. We're just creating our parts one at a time. So just like before, I'm going to right click and say edit appearance, make it look like it's made out of wood. And now we can go ahead and hit P to hide those planes so that we can just look at the part we're actually manipulating. So this part has fewer features. It really only needs one single slot because it's going to slide in right here. This slot's going to line up with any one of these 4 slots for this particular design. And so to make that happen, I'm going to click on this front face, make a new sketch, hit End for normal, and now we've got to define a corner point rectangle, which is the G key or this corner rectangle tool. I'm going to put it roughly in the position I want. I am going to let it snap to the center line for all the reasons we talked about before. And now it's time to hit D for dimension. Click on this, and hopefully you guessed that's going to be material thickness based on the wood that's going to slide into there. And its width is already set. So the only free unconstrained property of this rectangle is how high up and down it is. So I'm just going to choose, for this I think I'm going to go with 5 millimeters. That looks a little too high up actually. I don't want that much lean. So I'm going to say 3 millimeters. And we will call this the backstop slot. And I'm going to copy those because we're going to use that same name for the extrusion. So just like before, we'll extrude, removing material through all, and we'll name it backstop slot. And now we should see our back slot. Our backstop actually has a slot where it can slide into our base, which is great. So we've got 2 of our 3 parts completed at this point, or nearly completed. You'll notice I can't drag them around in this part studio like I keep doing over here. That's because this is actually an assembly, which we will get to a little bit later. It's not a part studio. So this is where you can relate your parts to one another and kind of visualize how they come together, versus the part studio is just where we're defining all their geometries. Let's go ahead and double check by changing material thickness from 3 up to 7 millimeters. And if we change that variable, you'll notice everything gets really nice and blocky. What we're really looking for here is, did this slot respond? Yes, it did. Our backstop also responded. Now this chunky cut here obviously is not the way we would want things to line up, but that's because of the way we've defined the sketch to be as thick as the material plus 1.5 centimeters in between. So this design would need to change a little more to accommodate such a thick material, but the good news is we're working in 3 millimeter wood. So the last thing we need to define is this little mushroom shaped front stop that keeps the phone from just, if we were to try and slide a phone right here, it would probably just kind of slide out the front of the stand. So we're going to put this piece there to keep it in place. So we are going to hit P to turn back on the planes. we're going to define this in the front plane, because just like the backstop, its main orientation is going to be in this kind of vertical orientation, and that's its main profile there. So we'll click on front plane, we'll make a new sketch and view normal to it. And the way I would usually go about making this is using a center point rectangle centered on this line somewhere above the origin. I'd make one of those, and then below it another one, and these are just kind of floating in space because I'm going to use my coincident tool to say that this line lines up with this line and the bottom edge lines up with this line. So now I've kind of defined the rough shape I'm looking for. I haven't related them to one another in terms of relative size yet, but let's go ahead and dimension this to be our material thickness. This is the tab, and this part is the tab that's actually going to go into that first slot we made in the base. And so we're going to make a new variable called short tab length, and it's going to be based off of, this is kind of cool, we can reference another variable within a variable. So we'll take our short slot width, and we're going to make it slightly larger so that we get a press fit. So we'll go 0.3 millimeters in addition to our short slot width. So that's going to make our tab just a little bit wider than the hole it's supposed to fit in, which should give us, with wood, a nice press fit. And if we need to change that value later after prototyping, we will. The last thing we want to do is define the last two dimensions of this part. We got to tell it how wide to be and how tall. So in terms of width, I'm going to go with a pretty arbitrary 2 centimeters here. That's not a terribly wide thing, but again, we're trying not to cover too much of the phone screen with this little piece that sticks up. And then in terms of height, this is again an arbitrary choice that we might change later, but I'm going to say let's make it 0.75 centimeters tall. That gives us an okay looking part that we may want to change the dimensions of later, and we'll call this the front stop. At this point, we can extrude that into the third dimensions, making sure we're creating a new part whose thickness is material thickness, and it's called front stop. We'll rename it over here, and we'll assign it the color of that same plywood material by editing the appearance. And so when we zoom back out, we can show that we've got 3 parts now, one of which is this little part we just created. So in a minute here, we're going to get to relating these in assembly and adding some of these nice rounded edges to make things look a little bigger so we can visualize, and then this will be ready for laser cutting and prototyping. I'm going to pause the video here, so I've got a class in a moment, but we will pick back up in just a second. Alright, and we are back. So when we last left off, we had completed the basic design of each of our 3 pieces, or at least the first draft of each of our pieces. So now we're going to cover how we're able to get these smoother corners to make this a little bit more accessible, a little bit less likely to accidentally scratch someone with sharp edges. And you'll notice a couple of places we haven't smoothed the corners. So we've kept these corners low because when the part is assembled, I'd like it to sit flat on the table. I don't necessarily want it to be able to roll over on this edge. And then anywhere we have tab and slot meeting together, we want to keep those at right angles. But we're going to use a tool called the fillet tool. So let's start with the base. We want to round these 4 corners of the base. And so I'm going to zoom in and actually just click once on that edge. And we're going to do that at all 4 of the corners. We're just clicking on each of them one at a time. And then we'll rotate around so we can get to this final edge. And once I've selected all 4 of the edges I want, I'm going to choose this fillet tool, or hit Shift F, and it's going to apply a rounded edge there, and we can decide what radius we want. Now, sort of our limiting factor is going to be this back or this top right corner in this orientation. You can see if I put in a larger number, I get a smoother round, and that's ultimately probably going to be fine here. But remember, there's only like 5 millimeters separating this edge from this edge, so I may want to go with a slightly less aggressive fillet and still round out the corners. So I think 3 millimeters is going to be plenty. You of course could change this later or change it to whatever you like. But with that fillet added, our base has been smoothed out at the edges. One other thing we're going to do is group all the stuff related to the backstop into a back stop folder, as well as the front stop. And we'll leave these fillets on the outside of any of the folders. So let's take a look at the back stop. There's just two corners we want around here. So I'm going to select that edge and that edge. You can kind of think of it as what edge would I be sanding if I was going to sand around onto this piece. We'll grab our fillet tool. For this one, I might bump it up a little bit. Let's say we wanted to go to 7 millimeters. Let's look at that from the front. I think that looks pretty aesthetically pleasing, so I'm going to say OK to that. And then we'll hide the back stop and grab the front stop. Again, we will highlight the edges one at a time that we want to have affected by the fillet tool. And we'll go ahead. This one's much smaller, so I'm going to start with 3 millimeters. Let's take a look from the front. I think that looks pretty good. And so we'll round that. So you'll notice when we show our parts now, they've got our nice rounded edges. The last thing I want to show you is how I actually made this little mock-up where I could slide the pieces and kind of mimic how they're going to fit into each other. You'll notice they're able to pass right through each other. That's because I haven't actually applied any limits to them. I've just related them along their edges, but we're going to do even better in this example. So these three parts are stationary because we're in a part studio. I'm not able to drag them. They're just anchored to wherever I defined their geometry using sketches. So if I want to actually start to relate them and test my ideas before I make a cardboard prototype, I can choose New Tab and create Assembly. So an assembly is a place where we can drag and drop parts that we've defined in Part Studios and then relate them to one another. And there's a lot of different things you can do here, but we're going to start by inserting. I'm going to go ahead and expand the Part Studio 1 list, and we'll start by inserting the base. So that should show up, and I'm going to hit the green check. If I right click on this base, I have an option to fix. Now, each assembly shouldn't have a maximum of one fixed component that we kind of base everything else off of. So this is now fixed in space. I can't drag it. We can hide the origin because everything's going to be based on where this piece is. Next, let's go ahead and start with the expanding this list, the front stop. And you'll notice if I drag out here, the part follows my mouse around. So I'm just going to set it somewhere where I can see it. Hit the green check. And we want to mimic the way, just like I had in this one, that this drops down into the slot. So right now it has too many degrees of freedom. I can drag it anywhere all over the part. So we're going to use something called mate connectors, and these are going to be called mates. A mate is a way that you relate two parts. So we want this part to be able to slide relative to this part only in the vertical axis. So we're going to use what's called a slider mate. So you'll notice once you select slider mate, as you hover around, you get this little set of axes kind of jumping around and clipping to different kind of key parts or key features on your part. So what we're going to do is, I like that this has the blue z-axis pointed upward. We're going to go ahead and select, let's do this front corner. So we'll check that front corner should be related to this front corner on our part. And this one happens to be working right now. A lot of times to grab the second mate connector, you need to rotate and zoom to get it just right. But if I click on that, if I just accept this, now we should see that my part is just like in the other demo, able to slide up and down. But let's go ahead and limit it so that when this kind of clicks into place, it stops. We can do that by double clicking on our slider and setting some limits. So I believe the positive Z direction is up. So we don't want to have any maximum, but we do want to say a minimum of 0 centimeters, and that should limit it so it can't pass through the part. Let's try this out. Looks like I got it backward, so it's the exact opposite. It's only able to go below the part, and that's fine. I've never really gotten the hang of setting these off the bat, but we can just swap that for a maximum of 0 and no minimum. Let's try that out. It looks like that's exactly what we want. So now this part will stop. I'm not able to drag it down into there, and we can kind of see the way that it's going to notch down into our part. We're able to see that nothing is sticking out below here. Now we'll talk about that in a moment. But let's go ahead and bring in our final part from this drop down, which is going to be the backstop. So I'm going to drag it kind of out of the way. That's about as far as I could get it. Let's drag this out of the way where we can see it, and it doesn't matter which of these we want. For now, I'm going to just mimic sliding it into this second slot. So we're going to choose slider mate. We'll choose one on this corner, but we want that blue axis to run along the edge we're interested in. So we've got the back corner. That's going to actually line up with this back part of our part. So I'm going to rotate around. So that should line up with this point on the part with the blue axis pointed parallel to the edge. That's great. So we'll hit check, and let's go ahead and take a look. So now we've got it sliding in and out, but again, we have no limits. So we'll go ahead and set a limit, just like we did on the previous one. And let's see if I got it correct. Backward again. That's fine. It's usually a little bit of guess and check for me on these. So let's see. Now it does stop when those two key points on our parts hit each other. And we can kind of simulate how this thing's gonna click together. Just like that. Now if we look from the right side, you'll notice this slot it happens to be near the middle of the part, so it's reasonable to expect that the overall stand would kind of lean back, and your 2 points of contact would be right here and right here with the table, and that would probably work pretty well for having your phone in there. What I think we probably would want to avoid with this part is having the whole thing lean forward and lay on these two parts. Now I would want to actually try this in real life after cutting it, but it seems to me that if that was leaning forward, your viewing angle would be pretty extreme. I don't know if we want that or not. If we didn't want it, one idea I had for how we could solve it is just to extend the tab on, let's hide the base. If we extended this tab so it came all the way down to here, basically extended beyond the material into which it plugs, then we would have almost like a second little table leg up front, and this might sit better. So I'm going to leave that change for another time until after we've actually tested out this prototype, but I think that this is enough for us to throw in the laser cutter and see how our phone stand works, see how we like the dimensions we set overall. Does it stick back far enough? How do we like the spacing on these notches? How did we do on the tolerance where we made our tabs slightly bigger than our slots, and things like that. So thanks for watching. I hope that this has been helpful.